This video will cover a lot of the similar problems that you're going to see on the second page of your test. So let's take a look. We've got perpendicular bisectors and angled bisectors. So we're told this is a perpendicular bisector, which means then S is a midpoint, and that means these two sides are going to be congruent. So if I want to find X, I'm going to take these measurements. 10x minus 3 equals 3x plus 39. And I'm just going to use my algebra skills to solve for x. I'm going to start by subtracting the 3x from both sides. That gets us 7x minus 3 equals 39. If we add 3 to both sides, we now have 7x equals 42, and divide out the 7, x equals 6. And now in number 9, we're given an angle bisector, and if we're bisecting an angle, we're cutting it into two equal parts, so we know these angles are going to be congruent. So let's set them equal to each other and we'll find what x is. 4x plus 2 equals 7x minus 37. I'm going to start by subtracting the 4x from both sides. And we get 2 equals 3x minus 37. Let's add 37 to both sides. And 37 plus 2 is 39 equals 3x. Divide out the 3 and we get 13 equals x. And let's do a refresher. We need to know this information in order to do the next few problems. So, what if a triangle intersects at the circumcenter? Well, remember the circumcenter is a point of concurrency that is formed by perpendicular bisectors. Incenters are formed by angle bisectors. Centroids are formed by medians, and orthocenters are formed by altitudes. So now let's take it 14. We are told that Z is the circumcenter. So right off the bat, if we know that Z is a circumcenter, we also know it is formed by perpendicular bisectors. So my perpendicular bisectors are right here. Now, because of that word bisector, we know Y, X, and W are midpoints. And that means we have congruency. So SY would be congruent to YU. TW would be congruent to WS. And TX will be congruent to XU. We also know, because it is a circumcenter, the circumcenter is equidistant from the vertices. So that means these lines here, anything I'm putting right now in green, if it is equidistant of equal distance, that means they are also congruent. So what are we given? We are given SY equals 19. Well, if SY equals 19, YU would also have to equal 19 because they are congruent. And we are asked that right here, so let's fill that in. TZ is 21. So that's this green line here. Well, if TZ is 21, that means SZ is 21, and so is UZ. And we were asked for SZ, so we know that that is 21. ST is 30. So this entire distance is 30. We also know that W is a midpoint, so are congruent. So if I just take 30 divided by 2, that is 15 and 15. So that means WT equals 15. ZY we are not going to worry about. You are not going to see that on your test. That would require the use of the Pythagorean theorem, and we are not covering that at this point. We are not doing 15. You might see something like 16. So we are told we have an incenter. So now let's think. What is an incenter? What is it formed by? Well, an incenter is formed by angle bisectors. So if I look, here's my angles. So what it's doing is it's creating congruency between the angles. It looks like we're not really asked for any angle measures, but let's just go ahead and mark this down. Those are going to be congruent. We also know from our relationship of the incenter, these two legs will be congruent. Those two will be congruent, and these two legs will be congruent. We also know the incenter is equidistant from each side. So here's my incenter, and here's the side. So again, anything I am putting in green right now is congruent. So now let's see what we're given. QT is 5. So if QT is 5, I know QT is congruent to QS. That also has to be 5. VU is 7. So here's VU. This is 7. So anything else, remember it's equidistant. That means SV and TV would also be 7. And what are we asked for? We're asked for SV. So that is 7. QV and PS we're not worried about. You will not see that on your test. That again requires the Pythagorean theorem. Let's go ahead and review triangle centers. So if you notice, you have a vertex being connected to the opposite side. It is creating a perpendicular line, but we have nothing else to tell us that there's any kind of congruency. These are altitudes. It's measuring the height of each triangle. So if we have altitudes, we have an orthocenter. On number 20, we have angle bisectors. The only triangle center that is built by angle bisectors is the incenter. Now on 21, we have a vertex connected to the opposite side, and we're told that these two, the leg is broken into two congruent segments, which means this point is a midpoint. Now notice, we are not told that any of these are perpendicular. So that means this has to be a centroid. And now, inequalities in triangles. Determine whether the side lengths could form a triangle. Prove your answer with an inequality. So in order to do this, if you have two of the shorter sides of a triangle and you add them, and that number is greater than the largest side, we can say you can have a triangle. If it doesn't meet that requirement, no triangle exists. So I'm going to take my two smallest numbers, which are 5 and 2, 5 plus 2, and I'm going to ask myself, is that greater than 10? Well, 5 plus 2 is 7. 7 greater than 10. Well, that's not true. That is not a true statement. So no, we cannot have a triangle with these lengths. Number 24, my two smallest sides are 15 and 37. Now my largest side is 50, so the sum of 15 and 37 would have to be greater than 50. 15 plus 37 is 52. So is this a true statement? Yes, it is. 52 is greater than 50, so yes. These could be the sides of a triangle. So given the measures of two sides of a triangle, find the range of values for the third side. So here what we're going to do, we're going to find the smallest value and the highest value. So if I take 48 minus 3, you always start out doing subtraction. Make sure you subtract the smallest from the large. You would never have a negative answer because we're talking distance. We don't measure distance in negative numbers. So that's 45. And then if I take 48 plus 3, that's 51. So that means that third side of my triangle has to be greater than 45, but less than 51. And notice it does not include 45 and it does not include 51. Anything greater than 45, anything less than 51. Let's do another. Take 24 minus 11, it's 13. And now we can add them. 11 plus 24 is 35. So that means I have to be, my side length would have to be between 13 and 35. And now we're given if two sides of a triangle measure 19 centimeters and 34 centimeters, check all possible values for the third side. So let's take 34 minus 19. That is 15. 19 plus 34, that's 53. So that third side has to be between 15 and 53. Does not include 15. This would not be a correct answer. So we have 21, 38, and 52. Two more. We're going to do 29 and 30. Give the angles in order from least to greatest. So if we look at our sides, if we're going least to greatest, the side that is the shortest is 8 meters, which means if I go opposite, find the angle opposite, this angle would also have to be the smallest. So I'm going to start out with angle B. So next up would be 9. Let's go across from BD. The angle across from BD is C. So that means C would be the next largest. Now 13, that's my largest side, so the angle opposite is going to be my largest angle. And now 30, let's go the other way. Now notice we're missing an angle measure, but we know that the sum of the angles of a triangle equal 180 degrees. So if you can even just grab a calculator, 180 degrees minus 57 minus 64, that gets you 59. So now let's go the other way. What is the smallest angle? Well, that would be 57. So in other words, the side opposite that angle would have to be the shortest side. So opposite of 57 is line segment KM. So line segment KM is the shortest. Next up would be 59. The line segment across angle K here is line segment LM. My largest angle is 64. So the side opposite 64 is KL.